So one of the best ways to really get to understand the iOS is to do a quick little demonstration from start to finish with the iOS. So what we're going to do is we're going to do a quick little demo, and I want you to make some observations about it. So I have a piece of paper that's plain, a book, as well as a piece of paper that's crumbled up. So what I'm going to do is I'm going to drop all three, and I'm actually going to ask for my assistant to come on over and help with this. So come on over. Okay, stay there. Alright, so what I'm going to do, just watch, make some observations, don't try to explain anything, and don't give any observations away just yet. Alright, so I want you to pause it, think of some observations, and we'll come right back. Okay, so let's talk about some of those observations. So Jonathan, can you give me a couple observations of what just happened here?
So when you dropped the book, it made a very loud noise. I almost wanted to cover my ears.
Okay, that's good. So the book made a loud noise when it hit the ground. That's one observation. What's some other observations you saw?
So this one fell straight down but didn't make any loud noises.
Okay, so the crumpled paper fell straight down but didn't make any noises. Okay.
No.
No, okay.
It just fell lightly and like the crumpled paper went straight down, but this one kind of like moved from side to side.
Okay. And how about the timing of them?
Like that one was the slowest. I think that one was the quickest, and that was one of the second quickest. I forgot.
Okay, no worries. Thank you very much. Appreciate the help. Go, go, go. All right. So now we made some observations. We tried to see that there's some patterns happening with all these different things. And our pattern is that if you notice, everything fell down, but they fell down at different rates. So we need to kind of create a model to help us explain why things fall at different rates. So I want you to take a second, we're going to pause it, and try to come up with a model to help explain why the book fell the fastest and why the crumpled piece of paper fell the slowest. So pause it and come right back. Okay, so usually at this point in time, what happens is we come up with two different ideas for our model. The first is what some students and some people think is that heavier objects fall faster. The book is heavier than the crumpled piece of paper, so the book is going to fall faster. Other people will come up with a different model. The second model that typically comes up is that, well, it's not so much that the books are heavier, it's that there's the air pushing up on them is what's affecting how things are falling down. So we have two competing models. So we're going to run a testing experiment. Now remember, when we do these, we're not looking to prove something correct. We're actually looking to disprove one of our models so we can eliminate it. So what we're going to do is the following. I'm going to take the book, and I'm going to put the piece of paper on top of the book. Now I want you to think about it. Model A is that heavier objects fall faster. So don't try to answer this based upon what you think is going to happen, but you're going to answer it based upon what the model says should happen. So if heavier objects fall faster, what should happen when I move my hand? Now if model B is correct, in that the air is pushing up on it, and that's what causes things to slow down, what should we expect to happen based upon model B? So I want you to pause it, come up with what should happen based upon both of the models. Okay, so if model A is correct, the book should still fall fast, whereas the paper should go back and forth. If model B is correct, in that the air pushing up is what affects the paper, then the paper should stay on top of the book, which no glue, no tape, no magic, and it should fall down at the same rate, if model B were correct. Let's see what happens. 1, 2, 3. So the paper fell at the same rate as the book. Now remember, we can't prove a model is correct, but we can disprove one of our models, and by showing that the two objects of different masses fell at the same rate, we were able to disprove model A. And like we said, we didn't prove model B is correct, but model B is still working good for now. And then finally, when we're talking about the aisle sock, we always want to talk about applications. Where do we see this? Well, if you think about things falling down through the air and controlling how quickly they fall down based upon how much air is pushing them up, if you've ever gone skydiving, that's a very practical application of that. So thank you, and I look forward to chatting with you in our next video.